4. A person kicks a soccer ball with an initial velocity directed 53 degrees above the horizontal. The ball lands on a roof 7.2 meters high. The wall of the building is 25 meters away, and it takes the ball 2.1 seconds to pass directly over the wall. A. Calculate the initial velocity of the ball. B. Determine the horizontal range of the ball. To find the initial velocity of the ball, we must use the givens, which are the ball is traveling 53 degrees above the horizontal, and our range, or dx, is equal to 25 meters. Our time of flight is 2.1 seconds. Our required is our initial velocity, which is delta vi. To better understand the situation, we can draw a diagram. From there, we can use the horizontal motion equation, delta dx is equal to vx times delta t, to find the horizontal velocity. From there, we can use the cosine of the initial angle to find the initial velocity. In this diagram, it shows our initial angle of 53 degrees. It also shows our dx, which is 25 meters, and our dy, which is 7.2 meters. Our time of flight is about 2.1 seconds. Using our horizontal motion equation, delta dx is equal to vx delta t, we solve for the vx, which turns out to be 11.91 meters per second. Using the cosine formula, we can solve for vi, which is our initial velocity. From there, we sub in our numbers, and we achieve a final initial velocity of 19.79 meters per second. For question 4b, we need to determine the horizontal range of the ball. Givens. We are given the initial velocity of 19.79 meters per second, and our delta dy, or our vertical displacement, is 7.2 meters. Gravity is 9.81 meters per second. Our requireds are its total time of flight, or delta t, and our total horizontal range, or delta dx. To find the horizontal range, we must first find the total time of flight, in which the ball remains in the air, using the formula delta dy equals vy delta t minus 1/2 g delta t squared. From this, we can use the formula of horizontal motion, which is delta dx is equal to vx times delta t, to find the horizontal range. First, we must find our vertical velocity, which is vy. It is our initial velocity times sine theta. Subbing it in the values, we can get a final answer of 15.8 meters per second. We can then solve for delta t, which is our time of flight. dy is equal to 7.2 meters as determined from the diagram, and we can sub in our vy, which is 15.8 meters per second. We also sub in our gravity value, which is 9.8 meters per second. From there, we can use the quadratic equation to determine delta t. We get two answers for our delta t, which are 2.675 seconds and 0.549 seconds. We can discard the second number because that accounts for when the ball is traveling towards the target. Therefore, our delta t is 2.675 seconds. With our new delta t value, we can then sub it into our horizontal motion equation, which is vx times delta t. Using our vx from our previous calculations, we can then determine a final range of about 32 meters. Therefore, our horizontal range of our ball is about 32 meters.